Alright, welcome to assignment video number 2. This is gonna help you finish your assignment number 2, hopefully. And there are only 3 topics that we basically need to cover in this, and that should help you to get through all the 7 questions that are there in your assignment. The first topic we're gonna talk about is motion. Then the second topic will be your difference between distance and displacement, and the third topic will be the circular motion over here. So let's talk about motion first. What is motion? Say you're looking at a basketball lying on the ground and you're here at the 0 point, just chilling. And if I ask you, do you see this ball moving? And this ball is just lying on the ground, not doing anything. Hopefully your answer will be not. No, it's not moving. But if I do this and wait, let me try to. If I do this and I move the ball, oops. If I do this and now I move the ball, as you can see, if I ask you now is the ball moving, you would say yes, it's moving. So what is happening when I'm doing this? I'm basically changing the location of this ball. Either it's coming close to you or it's going farther away from you. So now initially it was at 3 meters from you, now it's at 4, now it's 5, 6, 7, now it's coming close, and going back. So we say something is moving when it changes its position or location with time. So let's just go ahead and write this down. How do we define motion? Well, motion is nothing but when an object, like a basketball in this case, changes its position slash location, position or location with time. With time means as the time passes, the ball is changing its position. And here's a fun thing about motion, that it's always respect to an observer. So right now you are looking at the ball, right? You are right here, right? Smiling here, looking at the ball. And for you right now, this ball is stationary because it's not changing its position or location with time. That's why you say the ball is at rest. But say for example, if an astronaut was looking at this ball from the outer space, okay, then what would he see? Is the ball moving for him, the astronaut? Well, think about this, right? There is sun, and then all the planets are revolving around the sun, and the planet is also rotating on its axis. That's how you get day and nights, and when it revolves around the sun, that's how you get different seasons. So since the planet is always moving, the earth is always moving, it's rotating or revolving, the astronaut will actually see the ball is moving because the ball is on the planet. So the ball is right over here and it's moving with the planet. So the astronaut over here will actually see that it's moving. So for you, the ball was not moving because it was not changing its position with time. Whereas for the astronaut, the ball is moving because it is changing position with time. It's coming to different locations as the earth rotates around the sun. So be careful that motion is always relative. That's what I mean when I say that motion is relative. It depends on, this is my eye. I apologize, it looks weird. So it depends on who is the observer. So who is looking at the object. So let me give you an example. So for example, if you are sitting in a bus with your friend and the bus is moving, then your friend and you are sitting on the same spot, okay? In that case, if I ask you, is your friend moving for you? And imagine you cannot look outside the bus, it's completely packed and it's moving very smoothly. So you cannot really tell if the bus is moving or not, even though I tell you it's moving. Then for you, your friend is not moving because they are at the same spot all the time. The gap between you and your friend is not changing at all. Whereas if somebody was outside on the street and they looked at this bus in which you and your friend is sitting, for them, the bus will be moving, it will be changing its location. So if they look at your friend, they will say that yes, they are moving because they are going to be changing their location as they're looking from the outside. And this should help you get through your first 4 questions or first 3 questions in the assignment. So remember, motion is always relative. It depends on who is the observer, who is looking at it. So this is very weird, but this is also super fun, that when you look at a basketball which is resting on the ground, it's moving and it's also not moving. It's not moving for somebody who is on the ground and looking at the ball. But if somebody is looking from outside, for them the ball is moving. And the funny thing is, there is nothing in the universe which is completely at rest. We are constant, even though like you see your table, your chair, everything in your room which is stationary right now, but everything is moving because the planet itself is moving around the sun. The sun is moving around a big black hole in the galaxy. The galaxies are moving around something in the center of the universe as well. So nothing in the universe is actually at complete rest. And that's one fun and weird thing about physics, that everything is always moving all the time. So it can only be stationary for one person who is also not moving with that particular object, like in this case you and ball both were on the ground and the gap was not increasing or decreasing, but this could totally be moving for somebody else. Cool, so hopefully that should help you answer the first 3 questions. Motion is relative, it depends on who is the observer. If the location is changing, when an object changes its position or location with time, that's only when you say that it is moving. So anytime you have to check if something is moving for the observer or for you, see if the location of that object is changing or not as time goes on. All right, moving on to the second big topic, displacement and distance. This is very simple. Okay, so imagine that there's 2 points, okay? This is point A, this is point B. And you have to get from point A to point B. You can do whatever. Like you can do this and then come to this point. Or you could just go like this and come to this point. So let's call this path 1, the first one. Let's call this as path 2, the second one. So any path that you take to get from point A to point B is your distance. Distance is like you add everything up. However number of steps you took, you add them up together. It's like your Fitbit. It's never negative. If you keep walking, you keep adding it. Whereas displacement, on the other hand, is more like a straight line distance from any point to a final point. So this will be your displacement. If you go from A to B, the straight line, the shortest possible path is always your displacement. Whereas any other path that you take to get from one point to the other, like path A or path 2, in path 1 or path 2 in this case, that's going to be your distance. So how do we define distance? It's the total, let me change my color. It's the total path length that you cover. It's also in meters. You always usually measure it in meters, standard wise, like m. And displacement is the shortest path. So it's also a path, but it's the shortest path, or the straight line path. Straight line path between 2 points. So let's do a quick example, and that will make way more sense about what I mean by all this. So let's just say this is your number line or your road. Start from 0. Let's just say this is 1 meters, 2 meters, 3 meters, 4 meters, and 5 meters. And let's just say you are here. And you start walking, you come all the way to 4 meters. And then you decide to turn and come back to 3 meters. And if I ask you, now this is your final position. This is where you ended up, by going to 4 meter first and then coming back to the 3 meter point. Now if I ask you what is the total distance that you covered, so for the total distance you add everything up. So you went 0 to 4 and then back to 1. So you covered 4 meters while going from 0 to 4, and then you came back 1 meters. So that makes the total distance 4 plus 1, which is 5 meters. So if I ask you how much distance you covered 5 meters because that's how much you walked. But if I ask you what's your displacement at this point, so for displacement, all you care about is the initial position and the final position, and see what's the gap. So if I see from here, what's the gap from here to here? 0 to 3, that's just 3 meters. So your displacement in this case is just 3 meters. So that's the difference between distance and displacement. For distance, you add everything up, whatever path you took. But for displacement, it's always the shortest distance between those two, initial and final point. So if you walk all the way back to the origin again, say for example, then your distance would be 4 meters forward, 4 meters backward. That will be 8 meters. But your displacement, think for a second of, since you came back to the same position, your initial and final point are the same place, your displacement will be 0, because that's the gap between your initial and your final position. And this will help you solve the rest of the questions. Okay, one last thing. While you're doing question 4, an athlete is running around a circular track. And you might need an extra piece of information to solve this problem. So anytime you run around a circular track or any circle, the funny thing about a circle is if you know the value of the radius, so this is called the radius, the point from the center to the edge of the circle. If you know the value of the radius, you can tell how many steps you would have to take to go around the circle just by knowing the radius. That's one awesome thing about a circle. So this radius, like this path around the circle, is called circumference. So circumference is equal to 2 times pi times r. Pi is basically a constant number which value is 3.14, and r is just the radius of the circle. So if you know the radius of the circle, you can use this equation to tell what is the path length if you run around that circular track. So for example, if the radius was 5 meters, then the circumference of that circle would be 2 times 3.14 times 5, which will be like, this will be 10, so this will be 31.4 meters. You can check using your calculator. So that's how long this path will be if you walk around the circular track, 31.4 meters, if this was 5 meters radius. But yeah, that should be helpful to solve you question 4. And also don't worry about question 6 if that gets too confusing for you, because I had shown this in the class, but don't worry about question 6. You can leave question 6 out on assignment 2, but the rest of it you should be able to do it. All right, good luck.